Hi, in this video we're going to do two more examples where we simplify complex rational expressions. Again, complex rational expressions involve rational expressions within rational expressions. So we have fractions within fractions. So in the last video we discussed that there's two different ways of doing this. However, I'm just going to stick with the most popular, which is look at all the denominators and come up with the LCM. So in this case, my LCM, okay, is I've got a q squared. Here it would just be 1. Here it would just be 1, so I can essentially ignore those. And I've got a q. So when we're looking for a common denominator, when we have a variable, we simply take the variable to the highest power, in this case, q squared. Now once I come up with my LCM, I want to make sure that I multiply every single term by the LCM. Otherwise, I change the problem. All right, and that includes numbers 1. I have to also multiply that by the q squared. For the most part, students remember to do the fractions, but they forget the whole numbers. All right, and now we just want to see what this simplifies to. Again, you guys remember to do the fractions because we want to get rid of our denominators, and if you do this correctly, your denominators should all go to 1. Q squared over q squared goes to 1, so my first term here just ends up being 1. And now here, I end up with a negative 1 times q squared, so it's minus q squared. Now I'm going to turn my attention to the denominator again. Q goes into q once, q goes into q squared, and leaves a q. Okay, so my first term here becomes q, and then here, 1 times q squared leaves me just a q squared. And now if you've got that far, you're doing good. However, this one's a little quirky in that we can simplify it. This is a perfect square minus a perfect square. So this is going to turn into 1 minus q and 1 plus q. Remember that from Mr. Formula. A perfect square minus a perfect square yields square root minus the square root plus the square root. Okay? And notice in our denominator, we could factor out a q, and we would be left with 1 plus q. Whoops, this should not be a q squared. It should just be a q. Sorry about that. You are not seeing things. I am wrong. Okay, so now notice that 1 plus q cancel, and then we are left with just 1 minus q over q. And that's our answer in simplest form. Again, if you get to this part, you're doing it correct. Just look to see if it can be further simplified. So let's turn our attention to the second example. I'm looking for the LCM. Again, I'm looking for the common multiple of all my denominators. I have an a, I have a b. I have an a squared, I have a b squared. So the LCM is going to actually be my highest power of each variable. So it's going to actually be a squared, b squared. Okay? And now I'm just going to multiply every single term by my a squared, b squared. Don't leave one of them out, or you will get it wrong. A squared, b squared. Now once I've done that, I can go in and start canceling. Remember, if you've done it correctly, all your denominators should go to 1. A goes into a once, a goes into here and leaves an a and a b squared. So my first term becomes a b squared. Over here, b goes into b once, b goes into here and leaves a b, so I'm left with 1 times a squared b, so this is plus a squared b. In the denominator, I'm going to cancel, leave me b squared. And here my b squares would cancel and leave me a minus a squared. And now we can see if this would simplify. I can pull an a and a b out of each term in the numerator, and that would leave me b plus a. In the denominator, I have Mr. Formula again, or in other words, perfect square minus a perfect square, so this is going to factor into b B minus A, B plus A. The same thing we had above when we did 1 minus Q squared. Same formula. And now notice the B plus A's would cancel. So our answer in simplest form would be AB over B minus A. Once again, if you got to this point, you're doing very well. Just remember to look and see if it can be further simplified.